right, this is our last day on rational expressions. We're still going to continue talking about how to add and subtract and find those LCDs. But before we do that, let's quickly review some factoring. Here we have a binomial. We want to start by taking out the GCF. So our GCF would be 2x. That leaves us with x squared minus 8. And then we'll see that that inside is still two terms, still a binomial, so it could possibly be a difference of squares, it could possibly be a difference of cubes. So let's take a look. The x squared obviously makes it look like it's a difference of squares, but 8 is not a perfect square. 8 is a perfect cube, but x squared isn't a cube. So one term makes it not work for either one of those patterns. So this actually is not a difference of squares, and it's not a difference of cubes. So we have factored as far as we can go. And you just stop right there. All right, so what we're gonna look at, we're gonna continue looking at rational expressions that are being added or subtracted. So as we mentioned on example 3, when you have things in your denominator that could factor, you want to factor before you find the LCD. So take a minute, write this down, but then I want you to pause and factor the denominators and see if you can come up with the LCD before you come back and check. All right, so this bottom denominator here is a difference of squares. So we have x minus 6, x plus 6. And the next denominator has a GCF. So we can take that 2 out, and we have 2 times x minus 6. Once we factor, it helps us to be able to see our LCD. All factors of all denominators have to be represented in the LCD. So the x minus 6 has to be there. The x plus 6 has to be there. The 2 has to be there. And then the x minus 6, but it's already there. So we have everything. All right, so this first part, it has everything except the 2. The second fraction has everything except for the x plus 6. So if you haven't done it already, go ahead and pause and multiply by what it's missing so then we can combine those together. All right, so this first one, we are going to multiply the top and the bottom by 2. And then the next one, top and bottom by x plus 6. So we end up with 14x plus, I'm going to go ahead and distribute this, 5x plus 30 all over our LCD. 2 times x minus 6 times x plus 6. Now that numerator can be simplified. We want to combine the 14x and the 5x. So 14x, oh, I didn't want to write it down. I just wanted to combine it. 14x plus 5x equals 19x plus 30 over our LCD. And we want to see if we can factor anything, but the numerator does not have a GCF, so that's as much as we can do. Nothing divides out, nothing factors. All right, please try number 5, same idea. Get the denominators factored first, then find an LCD, then multiply each rational expression by what it's missing, then combine. So take your time, hit pause, come back when you're ready. All right, this one we'd have to factor out a GCF. The next one has a leading coefficient of 1, so it's easy to figure out what multiplies and adds. Our LCD has to include all the things, so x, x minus 6, and x plus 4. So if we look at our first one, it's missing the x plus 4. So we're going to multiply top and bottom by x plus 4. Our second rational expression is missing just the x. So we're going to multiply top and bottom by x. All right, so if I distribute the 5x into the x plus 4, I get 5x squared plus 20x plus 4x squared. All over x times x minus 6 times x plus 4. All right, if you made it that far, excellent job. We now have some things we need to combine together. 5x squared and 4x squared would of course be 9x squared plus 20x. We leave our denominator completely factored, don't multiply those together. And then we need to look at our numerator to see if there is anything common that we could take out. And we do have a GCF, so it has x in common. So 9x plus 20 after we take out an x. And it was a good thing that we took that GCF out because now we have an x in our numerator and our denominator that we can divide out. So these x's here divide to equal 1. So we're left with 9x plus 20 over x minus 6, x plus 4. All right, the last one that we're going to do is going to be a subtraction problem. But you're going to start it the same way. You're going to factor the denominators, find an LCD, multiply by what it's missing. Now to factor these denominators, you're going to have to split the middle. So it's going to take a little bit of time. So hit pause, go ahead and split the middle on each one of those, and then come back and check to see if you got the right answer. All right, so the first one, when we're splitting the middle, we find out that -4 and 1 are the two values that would multiply and add. Then we group and take out our GCF. And that first denominator factors to x minus 2 times 2x plus 1. On the next one, splitting the middle, we find out that -6 and -1 multiply and add to the 6 and -7 that we had there. We then group and factor our GCFs out and have x minus 2 times 3x minus 1. All right, so once it's factored, we can now figure out our LCD. We need an x minus 2. We need a 2x plus 1. This x minus 2 is already there, so we don't need it again. And then 3x minus 1. All right, so our first fraction is missing the 3x minus 1 that we will multiply on top and bottom. The next one is missing 2x plus 1 that we will multiply on top and bottom. All right, so when we multiply that first group, we have 3x squared minus x. This next one we multiply, we have to be really careful because of the sneaky subtraction sign. I would recommend changing it to addition and making that a -1 so that you remember to distribute it all the way through. So -1 times 2x minus 1 all over our LCD. And then we need to combine like terms and see if there's anything we can simplify. So 3x squared, nothing combines with that, but we can combine the x's to get -3x. And then we will bring over our LCD. And we'll look at that numerator and see if it can factor. Is there anything that multiplies to get -3 and adds to get -3? Nope, there's nothing that does, so the numerator does not factor. So that is our final answer. So with all of these additions and subtractions, make sure you factor first, then find the LCD, and multiply each fraction by what is missing from the LCD.